Good to catch it before we get into anything too substantial. So again, for the record, my name's Josh Kelly, and this is basically a statutorily required group of Act 170 of 2022 legislative session. It's a group looking at the role of depackaging in the food and organics management system, and this is our 5th meeting of this participant group, and the main charge of the group is at the top of the agenda today. And last time we discussed bringing in speakers, guest speakers. So welcome to our speakers, and want to make the most of their time and the group's time. And also the group started to discuss and react to some ideas that the agency put together on ways to possibly support the hierarchy or support or change things around source separation. So that was a beginning spot. I think there's been a Google Doc that the participants have begun on. I don't know how far that is. So anyway, we could certainly get into that. The next part of the agenda is to, I guess, have any discussion about the update on the draft policy document you guys were working on. I think you have the latter half of the meeting to get into some detail. But is anything you guys want to coordinate on while you're all here? We step back and let you have the floor.
I guess having been asked by the group to set up a Google document and Drive, I haven't heard back from many folks. So I guess I would love to leave today with the right email addresses to make sure everybody has access to that. First document, the law as it's written is put up there. I left it empty just for some comments for a little while, and then I've now added 2 comments myself. But as far as I know, most folks haven't been able to get to it because they haven't responded to me. So I guess I'm just testing the question of whether everybody has a Gmail account, and if that's not the case, then maybe we need to rethink forum for that. Does everybody have it? I know Steve doesn't, but like, Aaron, do you have a Gmail account?
Yes, sorry, I'm just rereading your email and I didn't realize you were asking us to let you know yes or no. So yes.
Yeah, or I just need the account so I can let you in.
Yeah, I have one.
Yep.
I think the hope is that you guys can start to edit something jointly as a group and hopefully reach that point. And if there's things we can do to support you there, let us know. Otherwise, I think that this type of a system is the easiest way with an in the cloud document that's shared. And hopefully that works. And so maybe after this meeting, everybody can try again at leading into that.
And then the other thing I just add, since we're doing just business stuff, I sent it out this morning. I didn't have a chance to get it out earlier, but you all have it in your inboxes, and Ben has printed them for everybody too. I took all the notes from the second meeting with the sort of visioning work that we did and put it into a vision statement that I thought, we went through that process. The idea of helping ground everything we're doing sort of in a future retrospective look. So everything in there comes from something that was said by one of the members. Everybody's voices were captured. But the verbiage is my own because that's what was required. So any editing is up for grabs, bring your voice to it. And I think that would be good for us to try to complete sooner than later, so we have something like that to kind of step off from with these specific questions. To that end, I wondered if that 2019 policy that you put in that FTP folder, if that was something we could print even today for everybody. Is there like access to a printer?
Yeah, I can probably print that during the meeting.
Because I think that would be helpful. Like the second question is like, should we retain the existing policy? And I think it's important to sort of see the whole history of the policy.
The issue with that, there's multiple versions. I mean, because obviously it was a working document internally, so we have, I think, 3 or 4 different versions.
Right. No. Yeah.
They are all posted to the FTP site.
Including that one, I didn't.
I put it when you sent it yesterday.
Yeah.
I put that version up. So
Are people
there's-
using the FTP site?
That's a good question. I don't have a good gauge on that. Have
Yeah.
people been in the FTP site and accessing documents at all, or is that not a good method?
I checked it this morning. I think I saw the most recent one you put up and yeah, that one, I think that one would be great to have because unless is that the same version that was in the,
I thought originally it was, that's why I asked for it to be added.
Gotcha.
And I guess as I'm thinking about it, like this is a formal, like everything in there is kind of evidence to the question, to the process that we're covering. So it'd be good to make sure we're all looking at it together.
Okay, I'll print out the version you sent that Dan was looking at today and try to get it before the end of the meeting.
That would be awesome because I think that we're all busy. So everybody, whatever paper we have, we probably look at more than electronic.
Yep, that's good feedback. Thanks.
All right, with that, I'd love to go to our speakers. And Dr. Roy, if you're still with us, I'd like to give you the floor. And Ben, thanks so much for setting this up, and really thank you to the speakers for attending today. Dr. Roy, is it helpful to give you a setup as to what we're looking for? Ben, you already kind of gave that to them.
Yeah, I think we did. I mean, but we're trying to keep it because we're so limited on time and we have so many people here today to present. We're trying to keep it to 5 to 10 minutes and then maybe a 5 to 10 minute Q&A. I know that's not enough time to go over your expertise, but just in the interest of keeping it brief, and we can always reach out again later if needed. So that's kind of the summary, I'd say.
Yeah, that's absolutely fine. We'll be brief. Let me just figure out the best way to share on this laptop. All right, can everyone see my screen okay?
Yep.
Okay, so I'm here with Kate Porterfield, and Sarah Hobson, another UVM student, also contributed to the data that we'll show today. So our goal is just in 5 to 10 minutes to provide a quick update on where our research stands on microplastics and organic amendments and food waste. Yeah. So just a background summary. I know some of you are well aware of this, but we've been at this for about 2 years now, developing methods to measure microplastics in food waste, digestates, and compost. This has been a challenge in part because standard methods do not exist for these material types. There are methods out there for environmental samples, such as water samples or more mineral soils and sediments, but these methods have key limitations for samples that are so rich in organic matter, such as food waste, digestates, and compost, and especially food waste. You have to think about it. We're dealing with a material that has organic matter that has not had a chance to be degraded in any way, whether that be in the environment or in a digester or composting operation. So there's just a lot of organic stuff we have to work with in order to try to find and isolate the microplastics. So we are among the first labs in the United States to develop and test these methods. There are some labs in Europe and Asia that are ahead of us, particularly some labs in Europe that we have taken inspiration from and modeled our methods after. So our work has been supported financially by Casella and the UVM Gund Institute for Environment. We also now are fortunate to have some funding from EPA to expand our analysis of digestates. We will be doing that in the next year or two. We also are going to be doing some life cycle assessment that is, that is relevant to this conversation. We will be looking at different food waste management strategies and the environmental benefits and costs of each of those strategies. And with that analysis, we will be integrating kind of the mass flow of microplastics with each particular management strategy. That work's just starting, and we really don't have anything to present on that and won't for a little while. Some of you have seen that we put out as a preprint a comprehensive literature review that was submitted for peer review a while back. That peer review process is going well. The paper is currently in the final stages of review after revisions. So we're really hopeful that within the next month or so, if things go well, we'll have a final version of that to share with everyone. Okay, so how do we measure microplastics in the lab? Well, there's multiple steps. It's actually a very challenging process to get all the way from your raw sample to eventually what folks like you and regulators really want is, what is the percent by mass of microplastic contamination in one of these materials? So the first thing we need to do is to try to remove the organic matter. We've settled on using hydrogen peroxide to do that. And that helps oxidize the existing organic matter, not all of it, but a lot of it, and gives us a much more manageable sample to work with. We then use visual methods in a dichotomous key under a microscope. So we visually sort through samples that have been sieved at different size classes to identify microplastics based on some key criteria that help separate them from other organic or other inert materials within the sample. And this is also a challenging process, and we've been working through several steps to try to improve that process, keeping in mind that we eventually want to make recommendations for how another lab or another group could pick up these methods and use them. So we're kind of working a way to try to make that as good of a process as possible. And then we're characterizing by size. So most labs around the world who are doing this work are focused on particles larger than 1 millimeter, and that's largely due to practical constraints of working below that size class. We have attempted to go down to 0.5 millimeters, and we are able to identify and isolate microplastics at 0.5 millimeter and above, but we have less confidence in those counts. And there's not a lot of other numbers out there for us to compare to because far fewer researchers have gone that small. We then characterize the particles in terms of their shape, 3 main types: films, fibers, and fragments. And we are working on ways to convert our counts to mass because we recognize that in a policy context, it seems like percent contamination by weight is really what's of most interest. So we've been directly weighing particles that we can weigh on a microbalance to come up with some conversion factors. We also have some literature-based estimates. And a final step in this process is to use FTIR spectroscopy to confirm or reject what we call putative microplastics. And I'll get into that a little bit more. Everything we visually ID may not be a plastic, and we may also miss things. So in some cases, we're pulling particles that we think maybe could be a plastic, but they don't really convince us totally based on the visual ID. So we're going to be testing some of those using the FTIR to see if we're potentially missing anything. And in order to do this, you need a polymer type library for your instrument. We have that instrument here at UVM, and we've consulted with a lab in Germany who's been doing this work on microplastics. So they were kind enough to share their library with us, and that will allow us to determine polymer types for what we find. So just the status of where these different pieces stand. We've established the methods for isolation, identification, and characterization. And we've completed analysis with those methods for the majority of 20 compost samples, 5 digestate samples from a digester receiving depackaged ice cream, among other feedstocks, 4 mechanically depackaged ice cream samples, and 4 mechanically depackaged food scraps samples. We've established methods. We know exactly where we're going in terms of the mass measurements and the FTIR. We have some preliminary conversions between counts and mass, and we'll show you what those are suggesting to us so far. But this analysis step is still underway, and we hope to be done soon. I really want to have this all ready for the next legislative session when I anticipate this conversation will continue, and we want to provide as much data as we can. So some caveats about, we're going to show you some preliminary data quickly here, a couple of graphs. These should still be considered preliminary. There may be some adjustments. What the counts we're going to show represent are what we call putative microplastics. So we assume these are microplastics based on our visual identification, but there's a chance some of them may not be. And there's also a chance we may have missed some. So our counts may go up or down a little bit after we do the FTIR steps to confirm and reject potential microplastics that we visually ID'd. We're only going to present for microplastics greater than 1 millimeter. These are best suited to our methods and for comparisons to literature and regulatory thresholds. However, if folks are interested, we do have data for particles between 0.5 millimeter and 1 millimeter. And really, the conversions between counts and mass are preliminary. We've only completed those so far for the digestate and food waste. We're working on it for compost. We're really close. We could probably provide an update by next week with those numbers if folks are interested. And we've started the FTIR process. We've got it working. We've got our library in. We've positively identified some particles, but we haven't factored that into the data that will be shown here today. Bottom line, our final results may differ from what we present today to some degree, but we do not expect these differences to be substantial. So we're not showing you anything today that we think is going to jump by multiple orders of magnitude. We feel pretty confident in sort of the ballpark we're in. It's just about kind of refining those estimates at this point. Okay, so to get into the data, let's just focus on the top graph here. This is for our compost samples. So we're showing you everything we've got analyzed so far. So we have several samples here that are labeled CN. These are compost materials where food scraps are not part of the feedstock. So theoretically, we would expect that these materials would potentially have lower plastic contamination if the idea is food waste potentially brings plastic contamination in. And indeed, we see very little microplastic presence in compost where food waste is not one of the primary feedstocks or not a feedstock period. So some of these are dealing with animal waste of various sorts. That's primarily what these composts are comprised of, along with other bulking agents and feedstocks. And then the other ones labeled just C, so C2, C4, C5, and so on. These are composts where food stock is part of the food waste is part of the feedstock recipe. So here we still have quite a bit of variability. We still have some samples that are very low. We're not detecting any microplastics in these samples, but we do have some that kind of range up to around 1,000 particles per dry kilogram. And these results are pretty in line with what we've seen from labs over in Europe. Usually we're seeing results in the literature for counts in compost in the tens or hundreds of particles per dry kilogram. So far our results are pretty in line with that for composts that are derived in part, at least, from food waste. For digestates we've analyzed, we see variability here, and we're kind of largely within the same range of kind of 0 to 1,000 particles per dry kilogram. One sample was a bit higher than that, but that's for the 5 digestates we've analyzed there. And then for food scraps, we have our data here. Actually, Kate just told me that it appears there was an error in FS5 here, so just ignore that one for now. Yeah. But all of the others are accurate. Something happened when we shared this between 2 computers. But FS1, FS2, FS3, FS4, FS6, and FS7, and FS8, you can go ahead and take a look at. These represent different depackaged food waste materials, and some of them are ice cream and some of them are food scraps, right? And as you can see here, still seeing some variability. We see higher counts, generally higher counts in these materials than we do in either the digestates or the compost. In a sense, that would make sense. We assume that when you mix these food waste with other feedstocks in composting and digestion, you're essentially diluting any of that contamination in those materials to some degree with other bulking agents. So these range in this graph from up to 5,000. That we do have one sample that didn't render correctly, FS5, that was substantially higher than the others. And we'll update this group with that graph after this talk. But that one went up to approximately 15,000. And that was one sample that was particularly high compared to the other 7 samples we had. And then our last graph I'll show you. I know there's a lot going on here. I'll walk you through it. So we have material type on the x-axis, and we have estimated putative plastic content greater than 1 millimeter on a percent weight by weight basis, dry basis. So this is mass of microplastics per dry weight of material. And our data are the black dots on here. As I mentioned, we only have these weight conversions finished for food waste and digestates. And then all of the other colored dots are different literature values that we included in our comprehensive literature review. And so we had some things to compare to across all of these different categories. And right now for compost, we only have the literature values on here. Although I can tell you, I'm pretty confident that all of our compost numbers will largely be lower than all of the literature values shown on this graph. And we'll update you by next week with that information. We also included this red dash line, which is the proposed limit under the H.501 bill that was being debated last legislative session. So that was a 0.1% weight by weight limit. And that would only apply to soil amendments. So material that would be going to soils, not necessarily the food waste itself, but the digestates or compost derived from that food waste material. And as you can see across both our data and a good chunk of the literature, we're seeing numbers below that threshold. But that threshold does effectively kind of chop off the high end in the data we're seeing in the literature. So, you know, as I mentioned in my testimony last session, I thought that was a reasonable limit. And I still think that based on our further work on this issue, if the goal is to try to remove highly contaminated material from going to soils. But the data we are providing is going to provide more information for people to discuss, you know, where that line should be drawn, if that is to occur in some sort of future policy. Right now, our digestates are at the low end of some of the literature values. But we do see some variability between our samples that spans, you know, at least an order of magnitude. And our food waste also, mechanically depackaged food waste, is kind of on the lower end with some variability. Our highest point is represented on this graph, would have been a little over 0.1% by mass. And it's in line with some other studies on mechanically depackaged food waste. And we also included some information here for source separated food and garden waste for plastic contamination. None of the data that are in color come from Vermont, except for the teal for the digestate. That's some work my student Brendan O'Brien did that did include, that's an average, including some facilities in Vermont, but not all of them. But they were all in New England.
And it's digestate solid.
And it's digestate solids. So this is where we're at so far. We're going to keep improving this. I expect our numbers to kind of wiggle a little bit on this graph, but not change dramatically. We will be providing this context to this group and others who are interested on request as we go. And that's all we brought to present today. I don't want to take up too much time.
Thank you very much, Eric and Kate. Appreciate it.
Yeah, thanks, you guys. We do have a couple of questions. Yeah, can you see who those are from? Ben, can you see who those are from?
Carolyn Gordon, do we want to ask the stakeholders for questions? We're still limited on time.
Yeah, maybe we should do that first, and then I can go to those. Yeah, participants, any questions for Dr. Roy or Caitlin?
Yeah. Do you have data on the background rates of plastics?
Can you specify what you mean by background?
So existing elsewhere beyond where you have this sample data. So perhaps side of a road, somebody's backyard, the front lawn of the state house.
We do not have original data of that kind, but we have reviewed that type of data for soils globally as part of our comprehensive literature review. And the rates of contamination in soils vary. You know, roadsides can be highly contaminated, for example, and some agricultural soils can be as well, some less so. But in general, we've seen some rates that are kind of a similar order of magnitude to the rates of contamination we see in these materials. It's a great question about multiple potential sources. That's something we've tried to stress in previous communications with folks in this group and others, is that this is one potential source of microplastics to soils, but there are others that should probably be considered at some point as well.
Eric, I was wondering if you could just go back to the sample slide with this, the second to last slide. And just if you could tell us a little bit more about what you know about the associated materials and practices with each of those data points.
Can you see that, Tom? Hey, Tom, can you see the graph?
Yeah, I can see the graph, and I guess
Okay.
if you could just sort of, you know, take us through the really high and low samples and sort of what the differences might be between them.
You know, we really haven't got that far. Sort of where we're at right now is kind of grouping them into two groups for the compost, the ones that had food waste as a feedstock and the ones that did not. We clearly see that the samples with food waste as a feedstock have a greater probability of having some level of microplastic contamination. But we have not really dug into, you know, why does C5 potentially have more than C11? Because, you know, it is interesting. We do have at least 1, 2, 3, 4 compost sites that are accepting food scraps and have no contamination popping up in our analysis. So we do want to try to look into that and try to figure out, are there certain things that those folks are doing that others aren't? It's a little tough with a relatively small sample size still, even though we did 20. I'm not sure we're going to be able to tease all of those individual management factors apart, but obviously there's some variability here. This seems to suggest pretty clearly that there's a greater chance of having some contamination if you're bringing in food waste, but beyond that, I can't say much more right now.
But will you be basically, I mean, because when you sampled, for instance, at our site, we answered some questions. I mean, will we get some high level correlation to, you know, source separation practices, for instance?
Yeah, I mean, we're going to do what we can with the data that we're collected. I don't want to make too many promises on that until I really look at what we have for that in Sarah's data set and see if we're going to be able to distinguish enough to kind of either group facilities by practice type. That can be a little challenging when there's kind of variations in the practices people are using. So, but yeah, we'll follow up with you, Tom, and everybody who participated in this study will receive eventually their own report for their facility, the sample we collected from their facility, and kind of get a sense of where they fall within the spectrum of our results.
Yeah, thank you. I'm excited for that. I guess part of, with this group in mind, you know, one of the things we're trying to connect is practice and risk. And so having some even high level differentiation, say within source separation, might be valuable to us. I guess my other question was, you know, I can appreciate why one would look at mass, but it does seem like elsewhere, like in Europe, there's a shift, like in Germany, towards surface area. Is that something that you're able to pull out of your work in some capacity?
I suppose we could estimate surface area if that was desirable. I mean, you know, what we're measuring directly is counts. And we do, you know, for some of our particles that are larger than a millimeter, especially, although some we think we can get measurements. We have a nice microbalance here at UVM that we can measure really, really small things on. So we're trying to get as many direct measurements as we can to use as conversion factors. But one thing that's popped up to me is, for example, we have 3 categories: fragments, films, and fibers. Across the digestates and food waste, we were mostly finding films with a small number of fragments and a very small number of fibers. Whereas in compost, it was a little bit more of a split between those 3 categories. So that's one reason we aren't using the same methods to estimate mass for compost. The fibers are really, really light. So you could theoretically have several polyester fibers in your sample, but the mass of those fibers is going to be incredibly small. I haven't really thought about it on a surface area basis yet, but if that's something that would inform the decision-making processes in the state, that's something we can estimate. Did you want to elaborate?
Yeah, I just I think that the measuring by surface area has some of the same weaknesses as measuring on a particle count basis because it can change. So you could add the same amount of plastic, and depending on the degree of fragmentation that occurs, which will depend on the type of plastic and also the degree of mechanical, degradation and other types of degradation, you could end up with obviously vastly different particle counts from the same amount of plastic, which is where the weight, I think is a slightly better effort to standardize. But I think surface area has the same weaknesses as counts in that, depending on how much the plastic is fragmented at the point that you're sampling, you would get really different measures of surface area, even though those different measures might not actually represent the ultimate ecological risk or the ultimate surface area that will be available down the line. Does that make sense?
Mhm. And I had one last question. Can you just tell us a little bit more with the depackaging samples? You mentioned food scraps. I know previous iterations, you guys may have done more sampling, but they were looking at pretty homogeneous streams. Can you describe, are you looking at mixed streams and where are those materials coming from?
Yeah, we are looking at mixed food scrap streams, and as a homogeneous stream, we looked at packaged ice cream. So, and in general, Kate, correct me if I'm wrong, we found greater rates of microplastic contamination in the packaged ice cream.
Yeah, so that high outlier there is
So-
an ice cream sample.
Yeah, FS5.
FS5.
Yeah, FS5, FF6, 7, and 8. Sorry, we should have labeled this. These are ice cream, and 5 should be much higher. But our averages are higher because of a few high outliers with those materials, and that's something that was interesting to us. That it seems like, based on day-to-day operations, the results could potentially change a little bit for those materials, or the sample, just having happened to capture more that day. Do you have any other ideas why we might see some high samples for the ice cream?
I do. I think because there is so much intra-sample variability. So with this plot, you're starting to see some of the inter-sample variability, variability between different samples. But we're doing all of these analyses in triplicate in the lab, and there's a ton of variability even within the same sample, which is consistent with what other people have reported in the literature, because unlike phosphorus and other sorts of soluble contaminants, microplastics are really heterogeneously distributed throughout a food waste matrix. So they're like hot pockets, and that makes for really variable sampling, which is part of the reason why it's so hard to kind of get at what is the normal range, because the range is really, really big.
Yeah. And so I think over time, as we've collected our samples, we're doing time composites, we're doing replicates, we're getting a better sense of where averages are, but also what the potential range could be in terms of the high and low ends.
I also think that from if you think about it in terms of how much potential plastic is going in to the depackager and how much is being pulled out, if you're putting in more plastic to start with, then you're gonna have more in the output, just because, you know, there's kind of a somewhat fixed efficiency.
Right. Well, and that's probably why the average so far has been
Slightly higher.
slightly
Yeah.
higher for the ice cream versus the food
Yeah,
scrap.
given we don't know if the starting plastic content is higher in the ice cream, but there's already an initial separation step with the source separated food
Mhm.
scraps. They're not perfectly source separated, but they are, you know, imperfectly source separated.
Yeah.
Which is what the next plot is showing.
Well, Dr. Roy and Kate, thank you so much. And I want to invite you to stick around as long as you can. But we have a question from Jenna, and then I'll go to a couple other of our stakeholders. This is the challenge with time. We were like, oh yeah, 5-10 minutes, and it's just we get in deep. So go ahead, Jenna.
Hi, Eric. Thanks for presenting. I'm from Ben & Jerry's, and I think that those ice cream samples are probably ours. And I was curious if you guys know offhand if the plastic happened to be blue, if you recall.
Often blue, yes.
Yeah.
Okay, because all right, that's like our overwrap over the pints, and I would think that would be something that could be physically separated really easily. So that's interesting to know.
Yeah, no, it's largely like, well, so this is in the ice cream samples.
Yes.
It's yes, many of the films are blue, green,
Mhm.
Yeah. Okay.
black. Those are probably the 3 most common colors that I've
Okay.
found. Yeah.
Cool.
I mean, yes, that'd be great.
All right. Thank you.
Sometimes you can actually get at it with color. So other participants have a question before I go to some other? Okay, I think, who did we have hands from?
Carolyn Gordon?
Caroline Gordon?
Yeah, thank you. I was wondering just how maybe the research team decided in analyzing the DPAC samples with a methodology that's focusing on the organic matter samples. Because I'm thinking of the technology also using so much water to create those pumpable slurries. And so I'm wondering if it would be worth considering also taking samples from the water to really go into the nanoparticles as well, and looking at what contamination occurs in that range. And it just sounded at the beginning like there might be more established methodologies available for doing water sample analyses.
Yeah, I mean, there are for microplastics, but nanoplastics is still, these are emerging contaminants. These have not been studied for nearly as long as most of the other contaminants we worry about in the environment. So there are some methods out there. We are not currently set up to measure nanoplastics in water. We've really just been focusing on the organic materials. And again, just to clarify, the reason we do everything on a dry weight basis is so that our results are not dependent on, just dilution with water. So you could add more or less water and that would not necessarily change our results because we're working on a dry weight basis. But, I don't know, there's been some reports of plastics in tap water. I'm sure you all have seen the popular press on this. That is not something we've really looked into.
Just from our own experience, Steve and I and some others were looking into what sampling methods were available. And that was one of the few that there actually is commercial lab capability and relatively cheaply to do water samples for microplastics. So that might be an option going forward, but just a note.
Yeah, and just so you know, Ben, those methods that kind of rely on filtration and then they kind of get all the particles on a filter and then analyze that filter. That's what just doesn't work for these organic materials that we're working with. And that's why this has all been so cumbersome. If that worked, we would have been done with this a year or more ago.
Yeah, I appreciate that.
All right. Well, in the interest of time, thanks so much. It's really, really interesting research. Let's go to Kyla Bennett, Dr. Bennett, if you're with us. Be great to hear from you next.
Thank you so much for inviting me to speak to you today. Just a little bit of background about me so you know how I'm approaching this. I have a PhD in ecology and evolutionary biology, and I also have a law degree with a certificate in natural resources and environmental law. So I'm kind of straddling the science and the law. I work for PEER, which is a national nonprofit, Public Employees for Environmental Responsibility. We are basically a whistleblower group. We support and defend local, state, and federal employees who work in the environmental arena. We're a very client-driven group so that we only take cases that are brought to us by our clients. And what I wanted to talk to you about today is something that is very relevant to microplastics, but something that I haven't heard brought up yet in your discussions, which is PFAS, per and polyfluoroalkyl substances, which are in these microplastics. And PEER got involved in the whole PFAS issue back in 2018 because of an EPA client. I have gone so far down the PFAS rabbit hole that it's probably 80% of what I do these days, unfortunately. The chemistry is very complex. I'm an ecologist, not a chemist, but I've learned a lot, and I'm working with a lot of famous PFAS scientists around the country. But basically, for those who don't know what PFAS are, they're a very large family of human-made compounds. We don't even know how many there are. EPA does not have a definition that they use consistently across the agency. So one of their divisions say there's about 6,500 PFAS. Another one says there's over 12,000. Some literature says there's over 1 million. Regardless, there are a lot of PFAS compounds, and we know very little about the vast majority of them. The bottom line is that the one thing that all these PFAS have in common is that very, very strong carbon-fluorine bond. It's one of the strongest bonds known to humans, and it's almost impossible to break, which means that all PFAS compounds are persistent. And when EPA looks at chemicals, new chemicals coming on the market or existing chemicals that they're reviewing, and I am a former EPA employee, just so you know, the three things that they look at are, they call it PBT, persistence, bioaccumulation, and toxicity. And when we're talking about the class of PFAS compounds, they are all persistent. Many of them are bioaccumulative, and those that we know of are toxic. And as far as health effects, I'm sure you've all read about it, but there are developmental issues, cholesterol, kidney and testicular cancer, thyroid problems, makes you less likely to have vaccines work for you, gives you more severe COVID-19. Now there's emerging evidence about brain cancer, a lot of really bad health impacts. And in fact, in June of 2022, EPA came out with an interim health advisory for just 2 of these PFAS. And these are the 2 most prominent PFAS, PFOA and PFOS. And they said that the lifetime health advisory for PFOA is 4 parts per quadrillion, and for PFOS, 20 parts per quadrillion. We cannot measure that low. We literally do not have the technology to measure those levels. So basically what EPA is saying is that there is no safe level of at least these 2 PFAS. And by the end of December 2022, so within the next 6 weeks, I fully expect it to come out the day before Thanksgiving or Christmas Eve, knowing EPA. They are going to issue some draft regulations, proposed rule on MCLs for these 2 PFAS and maybe a few others. They will not be as low as parts per quadrillion because it doesn't make sense. We can't regulate it if we can't measure it, but it will probably be around detection limit. So the reason I'm bringing this up is because there are huge liability issues coming down the road for states, for municipalities, for everybody with these new limits coming out. So what does this have to do with depackaging? So there was a July 2022 study, and I'm sure Dr. Roy knows about this, that shows that when food is separated from packaging, there is less non-food contamination, which makes sense. One PFAS, PFBA, was detected in 60% of samples that were tested. And the reason is that so many of our plastics and food packaging contain PFAS. We are just now learning how many plastics contain PFAS. In fact, there's a paper coming out that I think I'm going to be an author on because I discovered this issue, but trust me when I tell you, many of our plastics containing food have PFAS in them. They do leach into the food, but we're talking about extremely high levels. And what happened here is Pierre found PFAS in Anvil 1010. I know Vermont is aware of this because you guys, I talked to the head of the ANR about it. Pesticide, EPA determined that the containers holding the pesticide, the plastic containers, were so highly fluorinated, they had levels of parts per billion of PFAS, which were leaching into the Anvil 1010, which caused it to get into the pesticide. As EPA started doing more research and other labs around the country started to do more research on this, we discovered that these fluorinated containers are not just used for pesticides and motor oils and agricultural products, but they are used for food, even food that you can buy off the shelf in the supermarket. So what we're talking about here are massive potentials of contamination for PFAS. In 2021, EPA did a study that showed that food contact materials really are full of PFAS, and this is just a quote from their study. They said, "Much remains unknown about the risks to human health and the environment posed by the land application of food waste compost and anaerobic digestate containing PFAS. When present in land-applied biosolids, PFAS have the potential to be taken up by plants and crops and/or leach into groundwater, which can be consumed by humans or used for agricultural purposes." So now, when you separate out the packaging from a food source, the packaging contains more PFAS. If that goes to a landfill, you're going to get a lot of PFAS in the leachate, but at least there it can be treated. It can be treated either by itself or when it gets to the wastewater treatment plant. Can't get rid of it, but you can filter it out. When you apply it to soils, you're talking about a contamination that is going to last hundreds of years. My children, your children, your grandchildren will still be dealing with this contamination down the road. There's also a very great risk about inhalation of these microplastics that contain PFAS. Inhalation risks of windblown dust are very high. Microplastics, as Dr. Roy mentioned, can be very light. They're more susceptible to suspension by wind than natural soil. It poses a serious inhalation risk. It can cause breathing irritation, oxidative stress in lung tissue, and an inflammatory response. And the inhalation of the PFAS itself can cause acute lung toxicity and inhibit lung surfactant functions. Now, we even have a farmer that we're dealing with in Maine right now, who he and his family had to actually desert their farm, leave it behind, because of the drought that we experienced this summer and all of the dust. They were breathing so much PFAS from the biosolids that had been applied to their land. And one last thing I wanted to mention is that, yes, PFAS is ubiquitous. We all know that. It's awful. It's everywhere. It's a national crisis. So right now, it's all about minimizing the risk and turning off the tap. We can't just say it's everywhere, so it's okay to apply more. Adding more is nonsensical. It's additive. PFAS is additive. It doesn't go away. I often liken it to climate change. If we stopped burning fossil fuels tomorrow, the carbon dioxide in our atmosphere is going to remain level for a very long time. I apologize. So sorry. This is the perils of working from home. So sorry about that. So the bottom line is that if we stop burning fossil fuels, carbon dioxide is going to remain fairly steady for hundreds of years, probably, before it starts falling. Same thing with PFAS. If we turn off that tap tomorrow and stop putting PFAS in our products, we're still going to have that PFAS in our land, our soil, our air, and our water for literally hundreds of years. We have to turn off the tap. We can deal with it to a certain extent if we try to deal with the landfill leachate, try to filter it out of our water. But once it gets into our soil, it becomes this circular system where it's almost impossible to get out. There are incredible legal liabilities coming down the road because of EPA and states. States are filling the void where EPA has been absent because the past administration did very little. The Biden administration is moving slowly. Here in Massachusetts, where I'm from, we regulate 6 PFAS in soil, groundwater, and drinking water. We are going to be increasing that and lowering the limits. It's coming. It's coming. And I think it's very, very short-sighted to add more microplastics to your soil because, well, just because more microplastics by themselves are not good. But this PFAS issue is something that you should really, really consider. And I fully support the hierarchy that you have in your law right now, because I think that will help reduce the amount of PFAS in your soils. And surprisingly, Vermont has a bigger PFAS issue than I had ever suspected. We did a FOIA from EPA of a bunch of PFAS data, and I was shocked to see that as of April 2021, of all the states in the country, Vermont was the 4th highest generator of waste containing PFAS, which just shocked me because, you know, Vermont is green, you know, but you don't need to add more to your soil. And that will get into your water, your drinking water. A lot of Vermonters get their drinking water from groundwater. It's very, very dangerous. And I would urge you to really think about the PFAS issue associated with microplastics before you make any decisions. Thanks.
Thanks, Dr. Bennett. I'll go to Dr. Roy in a second. Questions from participants first?
Can you say a little bit more about that number you just threw out, the 4th highest in the country of waste generated PFAS? What that means is that's looking at all waste streams that have been sampled for PFAS and saying that we have a high number. It's not necessarily stuff that's being produced in state.
Correct. I guess you guys accept waste from out of state, and it's the EPA data are not great. I'd be happy to share the spreadsheet that we have. They just released new data, and I haven't checked to see where Vermont falls now. I don't know how comprehensive it is, but it did give a kilogram amount of how much waste you generate. I think a lot of it is imported, not necessarily produced in your state.
Yeah, we don't accept waste from out of state though, so.
Yeah, if you could, Dr. Bennett, if you could share that with me, Ben Gothard, you have my email. I'll circulate it to the stakeholders. That would be great.
Sure.
Thank
Yep.
you.
Yep.
Others?
Yeah, can you explain how are PFAS removed through the wastewater treatment process?
They're actually not. But what you can do is you can filter that water before you can either pre-treat the leachate from the landfills, or you can filter the water before it goes out into the point source discharge. So what we've found which is really disturbing, PFAS chemistry is really complex. And there are a lot of these, we call them regrettable substitutions of these PFAS that were made to replace the legacy PFAS of PFOS and PFOA. 8 major manufacturers in the US have voluntarily agreed to not produce PFOA and PFOS. Unfortunately, there is no prohibition on them importing it or using it. Moreover, many of these regrettable substitutions that they've developed to take the place of PFOA and PFOS have terminal end products that are actually PFOA and PFOS. So we still see massive contamination of these two, and we're seeing a lot of PFOA in our plastics. So in wastewater treatment plants, actually what happens is we have less PFAS in the influent than we do in the effluent, because something is happening in that treatment process, which is breaking some of them down partially and resulting in more PFAS. But my point is that if this isn't usually done, but if you have a landfill, you can filter that leachate, or you can filter after the treatment process, the wastewater treatment plant, before it goes into discharged into a river or drinking water supply. My town here in Massachusetts, we have PFAS contaminated water. I haven't been able to drink my water or shower in my water for 2 years now. We had to spend, we're a town of 23,000. We had to spend $9 million for a filtration plant, which is going to be going up this spring, thank goodness. So you can filter it out, but then that filter becomes hazardous waste because we can't destroy it yet. There are some new technologies where it's successful at a lab bench. We don't know if it's scalable, but they are working on trying to figure out how to destroy it. But what my point was, it's better to know where it is than to spread it across your soils, because it will get into your drinking water, your surface waters, and it will get taken up by your agricultural crops.
So if you had food products, say in a container that was sitting on a shelf that then you emptied out into a compost bin, could that technically contain PFAS in it because it sat in that container that had
Yes.
PFAS?
Yes, it could, but there's more PFAS in the container than there is in the food. I mean, the bottom line is FDA is going to have to stop allowing fluorinated containers, and they are looking into it right now. The PFAS in these fluorinated containers will leach out in certain foods, not all of them. Acidic foods like, tomato-based things or vinegar, perhaps. Not so much in less acidic things. But it is in the plastic. Some of it is not just on the surface, but inside the actual molecules of plastic. And when you break that plastic down into microplastics, it becomes more bioavailable. And of course, when you eat microplastics that contain or inhale microplastics that contain PFAS, it is going to get into your blood serum. So there are 3 exposure pathways for PFAS: ingestion, inhalation, and dermal absorption.
All right, let's go to Dr. Roy, and then if others have other questions, we can go back.
Hi, Kyla, thanks. I share concern about PFAS. I'm just wondering, with this issue with food waste management, we're getting ready to kick off a study where we're really interested in comparing trade-offs that might exist with different strategies. And so this, thinking about this topic you discussed is definitely relevant to that. You mentioned that in some ways there's advantages to sending material to a landfill and having the PFAS there. I just kind of want to push you a little bit. What are you recommending in terms of food waste management? For example, we do have some composts in our data set that have no microplastic contamination that we've detected, but the majority do. And in the literature, the majority of any material derived from food waste, whether that's separated by humans from its packaging or separated by a machine, has some level of microplastics in it. So given that fact, are you suggesting, and thinking about the benefits of diverting organics from landfills, and how are you thinking about these trade-offs within that context? Are you suggesting we should landfill these materials or?
Yeah, I'm sorry if I wasn't clear, Dr. Roy. What I was suggesting is that the packaging not be, the depackaging plants, you are going to get some, it seems to me, and from the studies that I've read, more microplastics than if you separate it out first. I'm not suggesting putting food waste in landfills. Definitely not. There's no good answer. I mean, think about the biosolids issue. We need to stop applying biosolids to our farms because of the astronomically high levels of PFAS in biosolids. I don't know what the answer is then. What do you do with them? I don't have that answer. To me, it always goes back to, we need to turn off the tap of PFAS. We need to make all non-essential uses of PFAS banned, because having waterproof mascara or dental floss that slides easier or a non-stick pan, it is not worth the health impacts of that PFAS. There may indeed be some essential uses of PFAS. So ultimately, that's my goal. In the interim, I'm just suggesting we have to minimize the amount of microplastics that get into our soil because of the PFAS. That's the only thing I'm saying. However, that can be done. I am not suggesting landfilling food. I realize that there are problems with that. I don't have the answer. I'm just saying, I just wanted to raise awareness about minimizing the amount of plastic that gets into your soil.
Okay, yeah, I appreciate that. I mean, I was working on a very different project recently, nothing to do with food waste, nothing to do with depackaging or microplastics, but we were trying to find a beneficial reuse for a residual material. This is not a biosolid. And you know, we ran PFAS analysis and we came out for some of our samples with really low levels that are similar to levels that have been detected in background soils. And I guess the question for everybody is, what do we do with that information, right? We have there's a little bit in there. It's not completely free of it, but it's also not extremely contaminated with it either. I think that's something that's a little challenging when you're working on these resource recovery and reuse questions, because oftentimes there might be, you know, detectable very low levels, and how should we use that information? So I just wanted to put that out there as well.
Yeah, I think, you know, when we're talking about very low levels of PFAS, when there is virtually no safe level of some of them, it doesn't, I don't care how low they are, they're dangerous. There's one study out that I am aware of that everybody throws in my face from Vermont about background levels of PFAS in your Vermont soils. And, you know, I'm not sure about that study, where it came from. I suspect that there are higher levels. I'm not saying there's anything wrong with the study. It is what it is. I'm just saying that I have to wonder if, you know, you have a lot of skiing, cross-country skiing in Vermont, and the ski wax has PFAS. Could that be one of the sources? I don't know. But the bottom line is, even if your soil is contaminated, adding more is not the answer. Just because it's ubiquitous doesn't mean that we should be adding more. It's like a bathtub. The taps are on full, the bathtub is overflowing, and we're bailing it out with a teaspoon. You know, we have to turn off those taps wherever we can. And that's not going to come from, you know, A&R. I mean, it would be great if the Vermont legislature banned products with PFAS, consumer products with PFAS, as many other states are starting to do. Maine is taking the lead on this because of all of the awful things that are happening to their farmers up there. I admit that Vermont does have some soil levels that are high, but to me that argues even more for being more careful about what you're putting in.
Dr. Bennett, thank you. I'm gonna move us along only for time. We have two other speakers to go to, and George Parmentor, I think, is waiting in the wings. And welcome to Dr. Raju Badareddy. Sorry about that. So let's go to George. If you're here, you're next in the queue. If you're still with us.
Of course, yes.
There.
Thank you very much. You guys can hear me okay?
Yeah, perfect.
Awesome, great. So you guys are really, this is a tough issues you're digging into, so good for you guys. We appreciate all the good work. I think I'm here to talk about Hannaford's food waste processes, how we deal with food waste in the stores that we have in Vermont. And I think I can walk you through high level and then see what you have for questions about that, if that makes sense to everybody. So we have kind of evolved into what we think is a very simple and clear-cut process because we do operate supermarkets. So we do have a fair amount of turnover, and labor becomes a really important aspect of the business that we have to manage very closely. So we try to make our standard practices as an internal supermarket language applicable across all of our stores, whether they're in Vermont or where they are in our network. So for our stores, the process goes like this. When we have safe, edible food we can't sell, our number one priority is to get that food secured and donated to hunger relief agencies. And that happens in a couple different ways for what we would call perishable foods or fresh foods. Think about bakery, deli, meat, seafood, dairy, those types of things that we wouldn't want to have sitting around very long. those get segregated and donated to community agencies, food banks, and soup kitchens. And just for rough numbers, in 2021, at the end of the year, that was 1.9 million pounds of food that was donated. And then there's another 600,000 pounds of food that gets back to Vermont through the regional food bank. And that's more shelf stable stuff. Imagine, a crushed box of cereal or a slightly dented can, stuff that would be able to withstand the transportation back to our distribution center to get allocated back to the food bank. So a total of, if I did my math right, 2.3 million pounds, with the vast majority of that going right into local agencies in New York. So when we can't recover that food for hunger relief, so it's either the date code has gone beyond what we can safely donate, or the food is obviously spoiled or in some other way not fit for human consumption. Most of our stores, Vermont being an exception, but we're working on that. I can say more about that. That food, we have partnerships with local small scale producers. So people raising livestock, chicken, sows, that sort of thing. That stores can have relationships with local partners to have that food donated. We ask for there are some specific things we require to be done and not be done with that food, is basically just guidelines, but we do ask the farmer to sign it. We keep track of that centrally. I've been having conversations with the Vermont Department of Agriculture and then the USDA folks located in Vermont, so we can build a process that would allow us to also donate that food in Vermont. I think we're very close to that. So we learned some really great things from talking with Vermont Ag that I think we would modify our standard practices across our entire network. So that's good news there. So for us, it's food donations for people, food donations for animals, coming soon to New York, we hope early in 2023. And then finally, and this is the part that really, for us as a business, really allowed us to really make great gains in this area. Everything else goes in our green food waste bins. They're 65-gallon toters. They're located in the cooled areas inside those departments we talked about. Everything, full stop, that doesn't get donated goes in those bins, in the package or not. And that material gets picked up twice a week by our service partner, AgriCycle Energy, back of store. The schedule varies store by store depending on route, but it's 2 days a week, usually a Tuesday, Thursday, or a Monday, Wednesday. I think I have approximately 2.5 million pounds of recycled food in 2021. And I think what really there was a big point in this process where we shifted from away from any food going into our compactors at all. And we've accomplished that milestone like last year, early in the year. And that the reason for that is because this process is very simple for our associates to enact. Like, donate it to people, donate it to animals, everything else, full stop, goes in the green food waste bins. So really, that was the big game changer for us when we were able to recover packaged food. Before that point, well, actually, after that point happened, our food waste recovery numbers went up by between 30 and 40%, depending upon what region we're talking about, to the point where we've actually audited our waste compactors 2 years in a row now to find out if there's food in those compactors, and we're not finding food. So we feel pretty comfortable that our food is all being diverted from local landfill. So I think I'll just pause there to see if I'm on the right track, if you guys have questions about any of that.
I had a quick question, George. When you're talking about the millions of pounds, is that region wide, or is that just Vermont stores, or is that
specific to Vermont? Yes.
Okay,
Yes, that's
gotcha.
just pulled Vermont store numbers.
Thank you.
You're welcome.
I'm wondering, George, if you could describe to us, I understand that some portion of the materials, the packaged materials that come into a grocery store that don't go into the waste stream at all and are basically hauled back to where they come from. Is that true in the Hannaford's case?
Yes, so that, I think what you're describing there is our product recovery process. So that would be the shelf stable stuff we talked about. So and it could be food and it could be non-food. It could be any product actually that for one reason or another is back in the store. We can't sell it, either the package is compromised or damaged beyond the point that somebody would buy it. Or it was returned by a customer, for instance, that would also go into that stuff. All goes to the back of the store, gets aggregated, goes back to our distribution center in Schodack, New York. And then there's a process there for that stuff to be scanned out. So we remove it from inventory. And then it, depending on what it is, we have a computer program that runs in the background. It gets scanned, and then the people doing the scanning would be advised, what they need to do with it. Do they need to destroy it, or can they donate it, or does it need to be returned to the manufacturer? And the lion's share of that gets donated. We've actually worked with our partners. So if it's food, we definitely want to recover it. And there are a lot of non-foods also, sometimes cleaning materials and other stuff like that, as you can imagine, or personal care items.
I had another question. Clearly, from everything you've described, you guys put a lot of care into trying to, capture resources throughout the whole process to the greatest extent you can. I had the honor of working with Hannaford's for roughly a decade here, collecting food scraps prior to depackaging.
Mm-hmm.
And one of the things early on, Hannaford's was really our poster child for good practice, and we held it up to many other grocery stores. And at the time, Hannaford's was not only separating food from packaging, but was also removing PLU stickers from fruit. And so I spent a fair amount of time in other communities, nationally and internationally, doing work in this regard. And everybody was extremely impressed at our capacity to source food that was not only free of packaging, but also down to the PLU stickers. We did a time study with the Swanton Hannaford's. I'm not sure exactly in what year, but possibly 2012, 2011. And at the time, it appeared to it was taking about 2.5 hours per week to pick all of the PLU stickers for the entire Swanton store, which, is about 20 minutes a day. In 2011, 12, I think you guys are averaging in Vermont for produce workers about $13 an hour in 2022. So in about a decade prior, my guess is that it was no more than $10 an hour. So for 20 minutes a day, it was costing Hannaford's, $4 to $3.50 to remove vinyl from the food scrap stream. And then eventually, basically, Hannaford's came to see Vermont as an outlier in practice compared to the rest of the Northeast region, and lobbied the Agency of Natural Resources to not have fruit stickers be considered a source of contamination. For the cost of, several dollars a day, given the profit margins that Hannaford's has, what would be the justification for not trying to remove a source of contamination when it really was pennies on the dollar for you guys?
And some of what you say rings familiar to me. I'm not aware that we ever lobbied anyone to have a process removed. That if that was a process we were doing, and I don't doubt it was, that was probably something was decided between the store and you locally. It's never been a standard practice of our company to do that sort of thing. And to be honest, we arrived at the process we have today because it streamlined a lot of activity in the back of store for us. And I know, sometimes that's difficult to hear, but for us as a business, it's important for us, especially now when our stores are understaffed, as every single store we run in New Hampshire doesn't have the staffing that's intended to be in that store. And that's not because we don't want people to work there. We can't find people. We can't find people to do the stuff that's already planned for stores in every single day. So we would probably have a really difficult time convincing anyone that removing those stickers was something that we could do, and not because it's something we didn't want to do, but just if any minute we spend doing something that's not serving customers and putting product on the shelf is that's taking away from our core purpose.
Yeah,
as
and
a-
I
as a
appreciate
business.
that. I run a small business too. I'm not fully staffed. I haven't been for several years. I spend a lot more time in an operational role than I have time for. But we're talking about something that happened well before the Great Recession,
Sure.
or the Great Resignation, rather. And it was an example of Hannaford's going from being really the high mark in the system that we use as a example for other operators,
Right.
to coming in and lowering our standard in Vermont. And I realize that you guys are dealing with regional stores and a bigger footprint, but for those of us on the ground who then have to deal with handling that contamination, your savings of several dollars a day amounts to a lot more impact on those of us that are probably dealing with much smaller profit margins than you are, and a lot less capacity to absorb that task.
Well,
It-
we shifted to a
I-
process to have AgriCycle take 100% of our food waste from every store in our network. I want to say maybe that same 10 years ago that you're talking about. And that was a decision that, we didn't take lightly. And certainly we are very in favor of composting. We love composters. We think it's a great use of business, but of food scraps. The problem for us was it never could take all of our food scraps, right? So
Yeah,
by
just- sorry,
taking,
quick-
by adopting AgriCycle, we're able to send all of our food. We're not sending any food to landfill at all in New Hampshire, Vermont, anywhere in our network, as a matter of fact, full stop. And that's because we have a partner who can take everything that's excess and can't be sold or donated from our stores. And as a business, you have to understand, and you do as a small business person, that's a very clean, efficient way to deal with it. And that's just where we ended up, to be kind of frank
Yeah,
about it.
point of information, I guess, AgriCycle did not come into Vermont until 2018, so we're talking
Okay.
about at least 5 years before that.
Yeah, you're right. It was one of
Yeah.
that was one of the last areas that we
We
rolled
not
it out.
rehashed 10 years ago.
Other folks have
But
questions?
these are relevant to our process.
To your process. I don't- Yeah.
We're talking about source separation and the cost of it. To look at some of these things and what the actuals are is highly relevant to the.
I don't
question
think
of-
that the retailers are placing the stickers on fruit, and removing stickers from fruit is not going to significantly reduce the PFAS in our soil. So I think you've made your point. I think that George is doing a phenomenal job expressing their operations. It's unfortunate that things have happened the way they have, but let's get back to the point of the impact of what has been proposed and how it's going to impact Hannaford and other stores operationally.
Well, I think the second question that we're being asked to answer is about source separation. And so the questions of how functional and impossible these things are, I think this is really relevant in that we had a history in Vermont of doing a stellar job. So it's not a question of, is it possible? We know it's possible. And so that's the piece that I'm trying to unpack to make sure that we're we're remembering history.
And I can appreciate that, but I think that 2011 is very different from 2022, and we need to be realistic in our process as well.
And I also think that for that second charge, we as a group need to work through that, not necessarily with somebody who came in to present to us. And so I'm totally up for having the conversation, but I think we as a group need to maintain that space.
Yeah, we're already over time. I just wanted to see, since Judy's here, if she had anything she wanted to add. I wanted to make sure, giving you the microphone and a chance if you want. Judy, now.
Thank you. I actually do the government relations work for the Hannaford brand in our 5 states. So George is truly much more of an expert than me on the processes, and we just work together as new rules and regulations are proposed in our states. So it's been great to listen in on the conversation. Thank you.
Great. But any other questions for Hannaford, since we are a little over time? Dan?
Just a quick one. George, I'm wondering if Vermont as a state went forward with a different interpretation of the current policy, and there was a requirement to do source separation differently, and and your goal didn't change, that you were trying to prevent everything from going to the landfill that might be organics. Would it be possible to do that with multiple bins of 65-gallon toters and just exclude one, put packaged material in one and non-packaged material in the other? Is that attainable? If that was the mandate?
I think we're assuming it would go to different partners. I mean, for us, we've arrived at a solution that we find works very, very well. It's one partner, it's, back of house, it's one invoice, it's a process we know, they understand our stores. So to answer your question, I did check in with some of my retail partners just to understand the labor situation in Vermont, and it's dire. Vermont's unemployment is the lowest in any of the states we operate in. The district operator I talked to, she's a straight shooter, and she just told me that any time we spend doing something other than serving customers, putting product on the shelf, it's going to be taken away from those core functions, and that's not something we would kind of like charge into like full of enthusiasm. We just have to be careful about the labor implications, and there would be labor implications. And all due respect, we would want to do our own evaluation of what that labor was. I wasn't involved in the process in Swanton, but it would be something we really want to take a hard look at. Like, how does that happen? What other decisions do our associates need to make? It's very clean now, and that's allowed us to prevent all of our food waste from getting to landfill, which based on regulation in Vermont that was our wish, is to hit that goal and be good at it, and that's what we tried to do. I hope I answered your question.
Partially, I have a quick follow-up, but so I appreciate the convenience of being able to put everything in one container and send it all to Maine. We've heard from lots of Vermonters that they aren't in agreement with that practice of sending stuff two states away, thinking that there is capacity to handle it more locally. And I understand that there's other grocers in the state that don't use AgriCycle and are able to do that separation. So I'm curious if that were the mandate, if you would actually be able to do it regardless of the staffing.
I don't know the other grocers, and I don't know if they're keeping 100% of their food waste out of the landfill. I could tell you that's the solution that we landed on. And I know AgriCycle is constantly evolving their model. I don't know that they actually truck it back to Maine. I would defer to them to tell us exactly how that's being managed today, but I think it actually isn't evolving. And if they found local partners in Vermont, I know they would absolutely leverage that. I know they absolutely, I mean, they're not any more keen in spending money on diesel and time than any of us are. So I would invite that conversation with them. I really don't know where, because it does change over time, but we rely on them to do the right thing with that food, which it goes to biodigesters. And I know the packaging is thoughtfully taken care of, but the details, we got to go back to them.
I think the other piece too, just being a hauler, and I know you probably have the hauling piece that does add another truck, another route, more fuel, more labor. So you have to add that in as well. So it depends on how the systems are set up, because you are going to have those struggles on the other end as well with trucks. And I mean, I know just from every hauler I've talked to in the state, we're all at capacity, and finding trucks and finding CDL drivers, even getting your trucks that we ordered a year and a half ago. Like my food waste truck that I put an order in for 2 years ago just showed up. So I think those are some of the constraints. We could make a knee-jerk reaction now, but if you don't have the assets to actually service the customers, then a lot of the customers are going to come back to us and say, we can't, you're not providing the service. So I think we got to factor those in as well, and not just, I get we can make a rule, but we got to look at it as a system, and how much capacity does Green Mountain have as well? Like, are you at your capacity limits too? Because that's the other thing that we run into. Once it starts coming to Casella, we've got to actually figure out where it's going to go. And if you can't accept it and you don't have a permit to take enough material, that adds a whole nother transportation logistics issues for us as well. So, and I get you may have capacity today, but does that change tomorrow too? So maybe even the state looking at that capacity map and actually checking it, because I know I've looked at the map before, and sometimes I call the people and they're like, hey, we don't have capacity, or we're not even open anymore, right? Which is hard to run a business that way.
I got a quick follow-up to Dan's question for George, just while you have you, because this came up at previous stakeholder meetings, and I'm hoping we can get some clarity on it. Let's just say, like, in a hypothetical situation, if AgriCycle, to streamline your contracting, if they offered 2 routes, right? If they offered 2 products and they were going to pick up, say, the packaged organics from you in one bin, and source separated produce or whatever else in another bin, Can you talk a little bit, I know I'm putting you on the spot a little bit here, but just about what that represents for each store in terms of the lift that requires to separate at that level?
I think what we find what we find is that anytime we introduce a level of complexity, and granted, you're not talking about, you know, like a huge level of complexity, but every time we ask our associates to make a decision about something different, right? So now there are 2 bins sitting there. I have this thing, I can't sell it. What am I going to do with it? We're going to have contamination. I guarantee you that will be the case. I won't even sit here and tell you that we're 100% of our 100% of the food that should be donated gets donated. It's a constant everyday education, reinforcement, struggle. And I think what we are sure about is that the simpler we make this for, you know, 25,000 associates to execute, the cleaner it is. And any complication makes it just the opportunity for contamination goes up, and we see it.
Thank you. And obviously the speakers have been excellent, and it's bringing up a lot of stuff for this group, which is exactly the purpose of our time today. So thank you so much to Hannaford, George Permentor, and Judy Knapp for being here. Dr. Batteretti, if you're still with us, and we'd love to hear from you. Thank you so much.
Can everybody hear me?
Yes, perfect.
My apologies to the previous speakers and to the group here. I had a class this morning, so after the class I just came by. And one more thing, you know, it looks like the network, the Wi-Fi is a little bit poor. If it gets dropped in the middle, please excuse me. So you can ask and then I can repeat if needed. Okay. All right.
Sounds good.
Let me share my slides. Where is the share button?
Top right corner.
Top menu.
Oh yeah, yeah. I'm still.
Yeah, it's like the opposite of Zoom. Sorry about
Oh yeah,
that.
got it. Thank you. Can you all see my slides?
Yes, perfect.
Okay, all right. Thank you. Let me start by saying good morning, everybody. And you know, thank you for inviting me to talk about this PFAS issue. And I'm kind of a little bit aware of depackaging problem through Kate's and Dr. Roy's work, but I haven't done any work in this area. But in general, and I have been working with PFAS and trying to develop some destruction and remediation technologies, and also trying to understand fate and transport aspects of these PFAS and various environmental contaminants. And I got an email from Ben asking me to talk about PFAS in the environment, and are there any feasible PFAS degradation technologies out there? These are some of the the words that I got from his email, so I made that as a title here. So I'm an associate professor in the Civil and Environmental Engineering department. I also formed a group with my colleagues here at UVM and Norwich and St. Michael's. We call ourselves as Vermont Initiative for Biological and Environmental Surveillance. We track various contaminants in Lake Champlain and other places. But again, that's a whole other story. So today I want to focus on this PFAS contamination problem and what the people are thinking about, what feasible technologies are out there and how we can use them, if possible, to control, manage, destroy these PFAS compounds. And if time permits, I will present some of the work that I'm doing in my lab, and I want to present in the end some summary of my thoughts, and then open it up to the group for discussion. Okay. Sorry. Okay. Do you still see my slides? Sorry about that.
Yep.
Okay. Thank you. All right. You all know about this problem. These are present in every products, right? AAA, metal coatings, electronics, food packaging materials, and that's the main topic for the today. But they are everywhere. So, I thought it might be relevant for this group. People have found PFAS on the food labels, packaging materials, recycled paper, and containers of fast food containers, fries and pizzas and cake bakery, the cake holders and so on. And also people found PFAS on packaging machines, because they are constantly exposed to the products containing PFAS and so on. So they are bound to get into, come in contact with the food, and it might ultimately end up in the human and environmental systems. So we already know about the various sources that contribute to the PFAS, AAAF, landfills. Some of the biosolids have these compounds, and the whole cycle of PFAS. The main, because of their environmental persistence, they might be released from an industry, get into the water, groundwater, or when they are destroyed or manufactured through aerosols, they get transported to different places, deposit on the food. Groundwater, if it's used, when it's used for growing crops, end up in the bioaccumulate and eventually reach through food to the humans and have some health impacts. So this is what we are kind of talking about, right? So there are, in the past 15 years or so, there are over 1,000 papers talking about the toxicity and the risk associated with the PFAS and how the amount of risk they pose to the environment and human health. There are, at least yesterday I was checking, there are about 1,000 peer-reviewed publications. So far in the past, companies have been, or manufacturers have been comply, like voluntarily, reduce these compounds and so on. But right now the need is enforceable standards. But we all already know the challenge is extremely limited data, and for a good reason. These are very, very complex class of substances to deal with. So, so this is what we are also kind of trying to do to minimize the risk associated with PFAS. And I would like to think about this risk as in terms of exposure and hazard. And hazard is always there, but now we are trying to decrease the exposure of these compounds to the life, human health and the environmental systems. And the exposure includes routes and accumulation of these substances, and ultimately coming in, contact with the thing that is at risk. There is this aspect, and then now as an engineer, I look at how can I develop some sustainable engineered treatment processes to manage, mitigate, destroy these PFAS compounds. And the third point is, okay, are there methods that we can, or tools that we can develop to detect these compounds in PFAS compounds in various environmental systems. This is like in reference to the sensors that we are developing in my lab, but that's a whole other discussion that I'm not going to talk about today. But I will talk about the treatment processes, or technologies, and so on. So coming to this emerging feasible solutions, EPA has put together a team. They call themselves as PFAS Innovative Treatment Technology, a PIT team, technology team, and that's PIT team. And after reviewing several literature, they came up with these 4 technologies that they found. They have a great promise in destroying or remediating contaminated waste sources. And those are electrochemical methods, and that's one of the things that I do in my lab. The other one is supercritical water oxidation, mechanochemical milling, and pyrolysis, and gasification. The fourth one is another thing that I'm also doing in my lab, meaning looking at landfills and emissions from there and what type of PFAS are there. So the first and the second one are my major focus. But again, these are the 4 technologies that people think are finding that they might have promise. There are 2 aspects to it. One is the treatment selection, which one is appropriate for a particular matrix that has PFAS in it, and what is the consequence of using the technology. That's where the process management comes into picture. For example, if one wants to use electrochemical treatment system, the size of this treatment system, and it all depends on the reaction kinetics. There is some kind of a threshold concentration that would allow this technology to effectively destroy these compounds. This can be used in a centralized or decentralized way, and also because of the electricity involved, operating costs and maintenance, that all comes into picture. But also every technology has an advantage and disadvantage. We still don't know what other byproducts may get produced through this treatment, but that's also a part of the research process. So similarly, supercritical water oxidation, people have shown evaluated this technology and found some good destruction efficiencies for certain types of matrices. Again, we still don't know if there will be any volatiles that gets produced and how to handle this technology. There are some research going on there. The other promising one is mechanochemical milling. This is also, again, this is kind of a newer, I think 2 or 3 folks might have explored this technology, but there is no field data associated with it. But again, same kind of issues. Are there any volatile organic compounds that might be generated? How to handle those, and so on. And pyrolysis, of course, we want to burn the stuff if possible. But if the incinerators are working perfectly, what is the destruction efficiency? Right now, we don't know. We supply very high temperature to break down these compounds, but after exposing to the high temperature, are they completely destroyed? What are there volatiles coming out of it? We still don't know yet. But that's one of the study that I'm doing, evaluating doing the mass balance and evaluating the destruction efficiencies at 2 different landfills in the flare gases and all that. But again, these are the 4 technologies that EP has put together and asked the team to evaluate further. And there is a lot more investigation going on to see if they really stand out. But what are these for, right? These are the 5 complex matrices that people really want to treat. Spent GAC, anion exchange resins, soils, of course, biosolids and sludges, AAAF, spent AAAF, and leachate. These are the that are known to contain high concentrations of PFAS due to various reasons, but these are the ones that we want to remediate and treat. So we know the characteristics of these things, and they have PFAS in them, so they needs to be treated. Here I want to kind of first present at what stage that each of these technologies are present and getting implemented. This chart here shows the kind of technology readiness level. So in the red, it says it's in the lab scale, research phase 1, 2, and 3, basics, principles, proof of concept, and so on. Development stage, like kind of a pilot systems, technology kind of validated by some folks and tested in some relevant environment, demonstrated in some relevant environment, whereas the green ones they're actually deployed in the field and they have demonstrated a consistent performance in destroying or remediating PFAS contaminated materials. So this is a crosswalk chart, showing on the top the 4 technologies that are being investigated for PFAS destruction remediation in these 5 complex matrices. You can see here electrochemical oxidation. It is in this yellow region, for example. It's validated in the labs, tested in some relevant environments, whereas the red is only the proof of concept, mechanochemical and pyrolysis. Proof of concept when it came to this spent GAC, remediating and regenerating these things. Soils, it's only all of them, I think, yeah. This electrochemical oxidation has been shown to destroy some, but it's only in the lab scale. Similarly, the pyrolysis, only in the lab scale, some good destruction efficiencies. Whereas mechanochemical for the soil treatment, it's in the development phase. Some pilot scale experiments are being done. Similarly, with the biosolids, people have treated biosolids with supercritical water oxidation, and also mechanochemical is in the late research phase. But pyrolysis have been shown to be effective in destroying PFAS in biosolids, or at least some destruction has been shown. But there's a lot more data is needed to they have deployed this in the field. They have been using this thing. So that's the one of the studies that we are now evaluating to see what is the actual destruction efficiencies that we are getting out of this pyrolysis of these wastes and so on. Similarly, the spent and unused AAAF, these are the different stages, whereas supercritical water oxidation has been proven to be effective in destroying PFAS in these AAAF. Similarly, with the landfill, it's still in the development pilot phase stage where this electrochemical oxidation and supercritical water oxidation are being explored to treat landfill leachates. Yeah, this is if you have any questions I can answer, or if you want to know what I'm doing in my lab, I can talk about it. Do we still have time?
Yeah. Well, definitely, I think it'd be good to go to questions if that works for the group.
Yep.
Yeah, thank you, Professor Batteretti.
Sure.
And am I pronouncing your name right? Am I totally doing it wrong?
No, it's correct. Batteretti. Okay. Thank you.
I guess I'll ask one question is just, are you feeling that there's promising treatment systems? It sounds like there's some that are green, which looks maybe promising. I don't know. What's your general opinion on that?
Let me present this to you. So promising, it depends. So for example, when we talk about PFAS, at least as far as we know, there are only the known ones. I don't know about the unknown. The known ones, there are about 9,000 different PFAS compounds. And of those 9,000 compounds, we can effectively measure about 30 compounds using the instruments available. That's all. And the remaining, it's you cannot even find them. We don't have standards to measure those compounds and so on. So with that so much of uncertainty, how can we truly evaluate if everything PFAS is getting destroyed? But at least with the two most commonly found compounds, we look at those P4 and PFOS and some other additional compounds, that 29 or compounds that EPA has put out. So we are looking at those 30 compounds. So we are destroying, let's take electrochemical oxidation. We are destroying them to in a very highly controlled conditions, but to use electrochemical, it has to be in some kind of a liquid concentrated form. Only then it will be very effective. Then so are we getting complete 100% defluorination, or are we generating some new byproducts which haven't been evaluated? So there is all these we don't have the data to come to that, oh, this is it, right? So this is where I think we have to be kind of careful. We have to look at individual technologies, but instead of looking at individual PFAS compounds, I think it would be very reasonable to look at what is the total organic fluorine. Because remember, there are 9,000 known compounds, but what else is there, we don't know. But instead of finding P4, PFOS, and all the dodecane and all individual compounds, let's look at what's the total organic fluorine in there. That will tell us. So if you're looking at pyrolysis, we will know how much fluorine is still out there, and we can do some things about it. So that way, I think that given the complexity, we don't have much data to make any decisions. So these things will at least get us to the starting point to carefully, consciously look at these products that we are using, and then make decisions accordingly to identify the technology. Yeah. So that's what. There are some more needs to be done. We need to evaluate depending on what matrix that we want to treat, and then specific to that matrix, we have to test these technologies. But we are getting there. I think you might have heard about in a recent news where Northwestern has just one paper that it got a lot of attention, low temperature mineralization. But again, it was done with a solvent, sodium hydroxide, and DMSO. But if first those things have to be concentrated. Then at 120 degrees Celsius and with these organic solvents, they were able to completely defluorinate. But it's in aqueous, highly controlled conditions. But if you put biosolids or something, it's not going to. It needs a different treatment. But yeah, so there are. Yeah, it depends which technology to use and so on.
Thank you. Yeah, go ahead.
After the material's treated, is it useful? What is it afterward, after it's been treated? Does it then have to go to a landfill? Can it be reused as something? What's the output?
Treated meaning like a wastewater or
Through any of these
biosolids or
processes, after
which
any of these
ones?
processes,
Which matrix? Is it leachate?
Maybe take biosolids.
or yeah, I guess take biosolids.
A triple F is firefighting foam. I don't think you're gonna use it for anything after that. But,
So
take biosolids maybe.
biosolids, yeah. We know these PFAS are because of the organic content in the biosolids, and PFAS really likes to stick partition onto the solids. One thing is we need to desorb them, desorb PFAS. One of the things that we are planning to explore is so now use electrical fields to make them unattached, desorbed from these things. So then at least we can get them desorbed from these biosolids into the liquid phase, and then use some membrane bioreactor to get the liquid out. So the combination that we are exploring is so we use electrical fields to dewater. This has been done before. They used electrical fields to dewater sludge to decrease the water content in the sludge. The same idea, but we manipulate the fields to not only dewater the sludge but also desorb to the extent possible the PFAS. So now you're recovering the water. You're also with that water the PFAS is coming. So now the solids, the liquid content of the solids is decreased. Now you have the water contaminated with PFAS. Now now that's where these technologies can come into picture to chemical methods or what is the other one? Supercritical water oxidation. These have potential to defluorinate, destroy these compounds. But again, that needs to be evaluated. Like I said, I was referring to the Northwestern study. They demonstrated complete defluorination at they call low temperature mineralization. If that works for this, real wastewater, that would be great, but it needs to be evaluated. So if defluorination has happened, then we can reuse it, apply it to the agriculture, or pass it through a membrane filter to get potable water. Water reuse can be done. So yeah, that's like
Thank you. Yeah.
way down there.
Were you asking also specifically about what happens to the PFAS compounds themselves?
Yeah.
No, I was just
If
trying to
that
find
is-
out what happens to this material after the.
If it's
I had one question.
defluorinated, sorry, if it's defluorinated, there's no problem, right? It's now just a organic carbon and fluoride. Fluoride ion is really good. We use it for dental. In water, we spike fluoride ions. It's good for the teeth. But anyway, that's a very ideal scenario. But yeah, so go ahead.
So given the scope of this committee to look at food and packaging and the risk and risk management, one of your earlier slides sort of showed the formula of risk and exposure, and then later you were sort of acknowledging how little data we have, how big the pool of total compounds are. What kind of, given your expertise and experience in this field, what kind of guidance would you give a group like ours that's trying to figure out policy in the interim before data is available of how best to minimize that risk and exposure formula?
Like I said, hazard is already there, right? It's like a knife, right? Knife, if it's in the hand, there is a potential for stabbing someone. But if it's in the drawer, no problem. Life, it's safe. But when it comes to the exposure, the knife, then that's where we are kind of wanted to know how to mitigate the routes. For example, like deep packaging materials that you're concerned about with PFAS and so on. So it's not. Every product might have some small quantities of PFAS, but some of them has more PFAS. And if we can identify these materials, like for example, what do you call I'm just fast food paper materials, the recycled paper, food wraps and so on. We already know these guys have more PFAS coatings and so on. So if we can separate them, at the source itself, that would give us some breathing period to evaluate the technology and then kind of manage. But also now these materials are coming from somewhere. Where are these getting manufactured? If it is manufactured outside the country, then we have to be careful. We have to be careful where we are getting and what we know about this product. Do they contain PFAS in them? So if we are become a little more conscious about it, at the source itself, we can separate these things and consciously get more the materials that have less PFAS in them. So because now, like I said, they are everywhere, but so at least that way we can add less to the environment and to deal with, given the complexity of these materials. So I think that's it has to kind of start up there, and the ones that are already there, then we have to see what's out there, how much PFAS is there, because we are crushing. After it's crushed, then if it's in solid state, it may not. It's still the hazard is sequestered. As soon as it gets exposed to acid or food as fatty acids, food the food that comes out of the container could be fatty, carboxylics, acidic, and all. When these two come in contact, that might result in leaching of this compound. So how to separate that food from the container itself that will not contribute to the leaching? It was initially sequestered, but now all the food is getting mixed with the liquid food and the solids that might enhance the leaching. So you have to be careful how to separate these things and so on. So I think if we can kind of focus on these things, we might be able to manage this for some time until the technology becomes available, field deployable, and so on.
I just want to thank you. It's been humbling to see expertise from all the speakers, and we're right up against time. So Dr. Batteretti, thank you for your time. I think we're engaged as a group. I think people are listening, and I think but that also probably goes for the stakeholders listening. And so to all speakers, thank you for joining us, and apologies if we ran over. I want to kind of steer us back. So Dr. Batteretti, thank you. And to all speakers, I want to kind of bring back to the group because we don't meet again until I think November 30th.
Correct.
And so our time is drawing quickly closer to less time. So before we run out of time, or if people have hard stops, I wanted to thank the speakers, but also come back around the table as a group. You have a lot of stuff. You have a Google Doc with some policy ideas in it. You have a vision statement Tom put together. You have the charge at the top of the agenda. And there was also some good discussion happening today amongst the group that we could start again next meeting. Was there other speakers, Ben, that were?
Yeah, so tentatively scheduled, we have Sarah Vos, the state toxicologist, scheduled for the next meeting, and also Brent Demers scheduled. He's from City Market. I think that was all we had. There's a couple of others that were tentative, but that's all we have confirmations from at this point.
Okay. What would you like your next agenda to be? And how can we help you proceed? I know that's a lot. I think given that that you've already asked for Cerebos and Brent, we will follow that path and try and get them here. We would propose a similar model where we bring them at the beginning and see if we have time for the discussion afterwards. The questions have been good, and I think it's been informative for me. I hope it has been for you.
I think if we could have the two presenters, obviously if folks want more, but I feel like we're kind of up against time and we may need to just stick with two more half hour for them. Probably an hour and a half of discussion and just kind of starting to talk through some of this stuff would be my thought.
How many more meetings do we have?
You have just the one scheduled right now,
That's the last.
November 30th, yeah.
But we had intended to have one in December.
Yeah, I
so we-
tried,
yeah,
yeah, but
okay.
yeah,
Ben
we can
would-
try again.
Really like for us to have this sorted out before December, if I remember.
That was the,
I also let we have the 15th of January to submit it, but also we, if there's, I mean, we can also go back to another doodle poll of sorts.
another, yeah.
I mean, it's the 9th today. There is time between now and the 30th. If you wanted to try for another meeting, I know I might get killed for even posing it, but I'm just saying there is still time in November. Holiday is the biggest issue.
That week of
That week
Thanksgiving
is
for
just
most
gonna be
people is
bad
usually.
For most of you, so. But December's an option as well.
Yeah, if we could try to schedule an early December meeting, I think that would be ideal.
Okay. You can help with that. And
Do folks feel like they could get on the drive and weigh in on the hierarchy stuff between now and next meeting so that then we could talk through and, use some of that time to process that and start trying to wrap some of that, or at least bring it a little further closure?
I mean, my whole take on a lot of this stuff is that there's a lot of unknowns, and I think doing anything is premature. Just, the PFAS, I've heard, take all organics and put it in the landfill because of PFAS, right? That was, Kayla said that.
No, that's not what she said.
But she did, well, she did at one point, right?
No, she never said that. She may still be on to clarify that,
She
but that was
clarified,
definitely
yeah.
not what she.
She cleared, but that's what I heard, right? So just my listening, and I'm saying, hey, if we're gonna do this right, there's a lot of science, there's a lot of stuff coming off. I think number one, we gotta ban PFAS as the state, but that's not our charge, right? So how do we get to our charge and what we need to do? And for me, that the hierarchy piece, I would say, my personal perspective, I would wait till we actually hear some of these other unknowns, right? That's just where I land. Just to give you my perspective.
I guess, do you want to talk at the next meeting about, it may just be that, opinion that you should, that perspective that you share. But I think we have a structure from Steve to do the last two speakers and then get into some stuff. As we discussed last time, there probably is not going to be agreement around the table on every idea this group has, and then we have to represent that in the report. And we're fine to do that. I think we anticipated that from day one, and that's okay. Steve, did you raise your hand? Did you?
No,
Sorry.
just clicking my
I
pen,
didn't
doing
want to be
other
talking
things.
I think another meeting unfortunately is probably really needed beyond the next one because an hour, it seems like there's a lot we haven't really discussed. I think this is all good and valuable information that we're getting, and we've started a little bit in a couple of directions, but haven't really gotten very far on them. So I'm wondering, like, specific to the three questions, if it makes sense to try to, I feel like we originally started to focus on one and then two a little bit, and maybe three wasn't really addressed directly as because it's kind of the overarching lens by which we're looking at all this, but like spelling out three next meeting, since I don't think we have done that one, or even source separation, we've touched on it, but I don't know, maybe like, I think that's what's missing is like, this is what source says, this is what we think source separation means. Now, what do we all think as stakeholders? What do we think the role of depackaging is in organics? Given everything we've learned from our guest speakers and where do we place the balance for these hazards that we are learning about versus the realities of our facilities and our collection and our everything else.
I certainly saw you guys getting into some debate about stuff, perspectives being shared, and that's what you've got to do. And so you need more time to do that. So we'll try and get you a December meeting.
I was just thinking, my observation from the group is it seems like it's more productive to have something written down to offer feedback on for the stakeholders. I mean, do you think that would be helpful to facilitate that conversation rather than just sort of a free verse kind of discussion around the table?
So, yeah, kind of, and even attack on to Ben's thought. This seems like it may be a lot for the next meeting, but could we each come to that next meeting with answers to those three charges? And do we just start there and kind of, if there's alignment between a couple of us, then there is. If there's not alignment, then there's not. And I do kind of agree with what Ben's saying, that the discussion can get pretty broad. It is an extremely deep topic, whether it's, on the waste side or it's the agriculture side. There's just so many different lenses to it. And I feel like we could talk around and around. I feel like if we could set as a goal, whether it's in the Google Doc that Tom set up or wherever is the right place, but just bring your 3 answers, or if you have 2 answers, bring your 6. I don't know.
Jenna's still there. Jenna, if you're still there, do you think
She stepped out.
she did? Okay, all right. I just wanted to make sure I try and recognize her so you can break in.
I know she was traveling, so I think she might have had another thing.
Folks want to come?
I also agree. I think
Yeah.
the draft proposal that was sent around, we've got 3 pages to all, I'm assuming we've all read through it and have our opinions, but it would be good to have, I think, answers to the three charges. Thank you. It's gonna call them questions.
Yeah.
But I think I appreciate the presentations today. I wish that we had more, or we had been able to hear from more people, but I think there's value in hearing from the stakeholders at the table also. And I think it's a good idea to answer the 3 charges, and that will give us a sense of direction and where we should go moving forward.
Do you want us to collect that before the meeting, or do you want to just bring it to the meeting?
Part of me is up for collecting it so we could put it up on the screen, but then I also don't know if that kind of locks people into spaces, and it'd be better to have kind of a more flexible,
Discussion.
yeah, kind of, so people aren't like, oh, well, that's what you said on the screen. It's like, yeah, that's my position. I'm also gonna have a conversation and allow my position to change. So I don't know what.
As I get more details in.
Exactly.
And maybe even what are the next steps too, like for this group too, right? Like, I don't, not that, yes, we have a deadline of the 15th and should be, have some recommendation, but what happens after that, right? In this space.
I mean, one outcome is you can recommend you want more time. Saying you want.
Anyone want to vote for that? I can for that.
Just, you get to make recommendations.
I think the other thing that would be helpful, and it is written down, and then we can have some commentary and go back and forth, is this vision tool. I think, will help us answer these questions. I think it's very, very useful practice to launch oneself 20 years forward and look back. And so I think that would be a good thing for us to have all read and also submitted some commentary between them so that we can look at each other's comments and kind of use that as a tool. And I'll just say I am very out of touch for the next 2 weeks. So unfortunately, I will be somewhat removed from that, but I already had a shot at putting language there. So it'd be a great time for everybody else to weigh in.
Will you be able to coordinate people getting access to the Gmail document or the?
Yeah, if I could get all those today, then we just get everybody in.
Can you just send the link to all of us and we can click on it? That's,
If I have your email address that's linked to Gmail.
and if you just send a link.
They're signed in.
Yeah, and you can. send it.
Not through like state of Vermont email you can, because
Yeah, I sent everybody the link and it bounced back to me. No, you never got it. That's why I sent the separate email, because Gmail was or Google's
Oh, and you
office.
just copy from the,
Oh, into the.
yeah,
Okay,
just copy and paste it into the body of an email, and everyone should be able to click on it.
Okay,
And
I'll
then-
try it that way.
And then if it's not the right email address, they can sign in through
A
whatever.
different one. Sure,
Yeah.
okay, yes,
Yeah,
I'll
let's do that.
redo that. So I think, Steve, you're then probably the outlier. I don't know about
work on
Gmail
with
either.
IT folks and see what I can do.
Let me know what you find.
I had
We're
to
having
set
the
up,
same issue.
It'll also take like 3 minutes to create a new, like just a total phantom Gmail account.
which is what I had to do outside of work for a different sharing of documents and access.
So, well, assuming that gets figured out, is that a good, you will put the document that you worked on up there for input as well? 'Cause I know it's on, or you put it on the FTP site, but
I don't mind putting in the Google site, but if like Steve doesn't have access to it right now, if it's a collaborative document, it seems like it should be in a place where we can all access it.
we can't edit on the FTP site, which
Right.
we could upload our own edits.
But yes, I will put it on the Google Drive. Can you?
I'll figure something out. I will get there.
Okay. Yes, I will put that up.
Because I mean, I have looked over it and it seems like a good thing to, in the Ben wrote all that stuff that we're hopefully gonna react to. This is, apart from that, I think this is like the only capture of stuff that we've all talked about to some degree based on that meeting many meetings ago. So it'd be like whatever this ends up becoming, I presume that some version of that would end up in the report or attached to the report.
Certainly good.
So it seems like a good thing, like in addition to answering the 3 charges by the next meeting, coming up with something, bringing a physical, whatever you want to share at that point, right?
So if we take our next meeting, we have 2 hours, 30 minutes for the 2 presenters, it leaves us an hour and a half. Should we just split that up into half-hour blocks, work through those questions? For the charges, 1, 2, 3. Do it that way.
Time expires, we stop.
We can have a whistle. Somebody could even bring a whistle.
30 minutes, yeah.
Yeah, because otherwise we'll just take the entire 90 minutes.
On topic 1, yeah.
Everybody's in agreement when the 30 minutes is up, we're moving on,
Yeah.
right?
And then we will clean up on the subsequent meeting that will be scheduled, yet to be scheduled.
All right, we will try and find another time for you guys, in December at minimum.
And thank you guys for organizing. I know I took in a lot today.
I think it was all really good. It was good to hear from stakeholders.
Yep. All right.